Hello, everyone. Welcome once again to my YouTube channel. Today we'll be looking at machine learning model deployment process. That is how to deploy machine learning model. And I'll be doing it on an Android phone, on a mobile phone. We are going to see how to deploy a machine learning model using Flask API and an SQLite database. You can also apply the same process on your laptop or anywhere. So it's just to know the process of deploying a machine learning model. So we are going to be using the data set we have been using in our previous machine learning videos. We're still using the data set here, and that is what we're going to be deploying. So sit back, relax, and enjoy your learning. Okay, so this is our code. This is our machine learning code that we'll be deploying. So first and foremost, this is a random forest model, and the data set we're using is the data set we've been using for my previous machine learning videos. So you can see the first library that we're importing is Pickle. Now that is what will be used to save this model. It is saved using Pickle. Pickle is like is like you're saving the model in a way that it can be easily interpreted when it's going to be deployed. So that is the way it is. So we have Pickle, then we do have the other libraries, which if you've watched my previous video, you should be familiar with. So this video is about machine learning model deployment, not about writing code. So we'll just go through this code quickly without wasting much of our time. So we'll go into the deployment. So we have our machine learning data set, which is what we've imported here. Okay, so this is a time series data set. So we have this line of code. We convert our date column to date time. Then in this machine learning model deployment, we decided to create extra columns. And one of the extra columns is this previous day visit. And the second column we created is 7-day moving average. Just like our previous video when we talk about SARIMA, which is a time series forecast model, we have the ACF and the PACF. So these two fit into the ACF and the PACF. So we are creating those two extra columns to add more information to our data set so that the model can be more robust. So for the two newly created columns, because of the way it's created, one of them, like this previous day visit, if you view the data set, the column, you will discover that the first cell of that column will be empty, no values. Then for the 7-day moving average, the first 7 cells of this column will be empty. So because of this reason, we have to fill the NA. I decided to fill the NA, that is those empty cells, with the mean of the whole values in the data set. Then we have our categorical columns and we have our numerical columns. Now, because this is a time series data set, the columns that have numbers, whole numbers, are our numerical columns. Now, if we check the data set, let's look at the data set. So here is the data set, which is the data set we've been using for our previous machine learning videos. So we can see these are our categorical data sets that has words in them. Then these are our numerical data sets, this ones. Now, the reason why I will not be adding this column that has zeros and ones is because when you are using a scalar, especially min max scalar, there is usually issues. It throws an error. So we'll focus on the columns that have numbers, whole numbers like this, the humidity, precipitation, temperature. Those are the columns we are focused on, and wind speed. So that's why I reference those columns. So now those are the columns here: temperature, precipitation, humidity, wind. Then the added columns, previous day visit and 7-day moving average. That's these two columns that were added. So they are our numerical columns. which we decided to normalize using the standard scalar. After normalizing them here on this line of code, we overwrite them. That's what this line of code does. So these data numerical columns, when we do the standard scalar, it will overwrite the values there. Then we use label encoder for our categorical columns, which is the weather condition and day of the week. Now we have to separate our data in the form of X and Y, where your X is your features and your Y is your target. So our target for this data set is our park visit count column. Now, for those that are just watching this video for the first time, you've not watched the other videos, the data set contains information about a park, about different parks, and the park visit count column is the count of the total number of visitors that visited the park each day. So now what this machine learning model wants to do is to predict the number of visitors that will come in subsequent years or subsequent months. So that is what this machine learning model is doing with this data set. So in this data set, we have the temperature, we have other informations. Let's look at the data set. So we have the date, the day of the week, we have the holiday indicator, the temperature, precipitation, humidity, wind speed, the weather condition, weekend indicator, whether school is on vacation or not, whether there is an advertisement on that day, whether there is a special park feature, and finally the park visit count. So with this information, we want to be able to predict, okay, what's going to happen in 2025? How many visitors are we expecting in 2025? So now having this information at the back of your mind, so our Y is our park visit count. That is what we want to predict. Then our X contains every other information except our date column and park visit count column. So as usual, we split our data set. The reason why we are splitting data set is so that we can use the test data set to test our model to see its accuracy, whether it's predicting well. So that is the reason. So we split our data set this way. Now take note, I repeat, this is a time series data set. Let's go back to the data set so that you understand in case you've not been following my previous videos. Now look at a time series data set. It follows the date. For example, we can see this is 1st of January, 2nd of January, 3rd of January, 4th of January, and so on. That's how it follows from 2020 to 2024. So we can see where the data set is being split. Now, on a normal day, the normal standard is to split it 80 to 20%. That is 80% for the training data set and 20% for the test. But in this case, I didn't split it that way because I'm only putting 0.01% for the test size. And the reason for this is because the data set had a spike. There was a spike. Now let me show you a chart of the data set. So this is the data set here. This is a chart showing the data set. We can see from 2020 to 2023, December 2023, the data set was within a range of 0 to 250 visitors. But in 2024, there was a sudden spike. You can see it that it shot up to about 2,000 visitors, which it has been ranging between 1,000 to 2,000 visitors throughout 2024. So because of this sudden spike, if we split the data into 80% to 20%, the model will not take cognizance of this spike that happened in 2024 because the whole of 2024 will now be in the test data set. Meanwhile, the trained data set didn't have the information that there was a sudden spike in a particular period in this data set. So for me, I chose to train the data set with almost all the data set and just pick little of it to test its accuracy. So that is why I did what I did. So we can see also that shuffle is set to false. We are not shuffling the data set. It's advisable when dealing with a time series data set, you don't shuffle it. If you shuffle it, you are going to distort everything. You will distort everything because the information of yesterday, the information of today is determined by previous day information. That is where the PACF and ACF come into place in SARIMA. So that is the autoregression information. So you don't shuffle a time series data set. Okay, so now we are training our model with a random forest regression model, and we decided to make the maximum depth 20, minimum sample split 2, number of estimators 100, and random state 42. Now, how did we come about this? Somewhere along the line, I had done a grid search. I had done hyperparameter tuning. That was when I came about this. Now, we are not going in depth into hyperparameter tuning or training of model. No, what we are focused on is model deployment. I just want to run through the code for you. So this is what we came about, and we use these parameters to train the model. So here we fit the X train and Y train into the model, and this line of code we predict the model. So we check for accuracy using this line of code. So when we check for accuracy to see how much the prediction worked, whether the prediction was as accurate as possible. So that is what this line of code does. Then this place is where I use to print out the values for X and the value for Y. I won't be printing it here because I already have that information. Now, this X test 1 and Y test 1, that is, take note, we have already split the data set into train and test data set. So the test data set, this line of code is saying for the test data set, the features, print out the first rule. And for that same test data set, print out the first value for Y. Take note. Let's go back to the information. So let's say we have split our data set, and every other, let's say this is where the row starts for the test data set from here downwards. So if it starts from here, so this whole information for X, for that row 26 will be printed out for X test, and this information 72 is the result we are supposed to get if we predicted the information for row 26 accurately. So now let's go back to our code. So that is what this line of code. So I've already printed this information already. It's in another part of my sheet, and this the result we are supposed to get for this information. Take note, we're testing the model. So this is the code that saves the model. So this code saves the model with pickle. You can see pickle here. Pickle is used to save the model. Then once the model has been successfully trained, it shows trained successfully. So let's see how it goes. So the code is running. So if it's successfully trained, you will see trained successfully. And also let's see what our RMSE score is. Now, in my previous machine learning video, we used other models and we saw their results. So for this one now, the RMSE is giving us a result of 266, which is not bad, but it's not so good, but it's not bad. In subsequent video, we will be using long short memory to train our model. That is a RNN model, a deep learning model, to train this data set so that we can have more accurate results for our forecast. So we can see our model has been successfully trained. So now, once our model has been successfully trained, the next thing is to deploy the model.